So this video comes as a 4-part series on ICA with the full tutorial documented on my website. This initial video talks you through the process of cleaning your data. There are two main approaches you might follow when preparing your data for ICA. The first is to create a second dataset solely for the purpose of ICA, then to import the ICA weights from this dataset into your original dataset. This isn't the process that we'll follow here. However, if it's your preferred method, take a look at the 4th video in this series, entitled Improving Your ICA Decomposition. There's a link below. The second method, and the one we'll go through in the present video, is to prepare the original dataset for ICA without creating a new set. You can choose to use whichever method you prefer. The former may mean that ICA runs quicker and produces better decomposition, particularly if you have fairly noisy data. But the approach we'll follow here will take up less space on your PC if file size is an issue. It's less time intensive and may work sufficiently well for your purposes, although running the ICA itself might take a little bit longer. So, to prepare the dataset for ICA, we're going to visually inspect and clean it. Although you should obviously ensure that the data you collect is as clean as possible, all data will have periods of noise because participants are only human. Give them a break in a testing session and they'll almost inevitably make more noise than you thought humanly possible in the space of 30 seconds. So we need to remove these breaks between your experimental blocks. This can be done both automatically or manually, but I'll talk you through the automatic rejection here because it'll save you a lot of time. So to do this, you go to EEGLAB, Pre-Process EEG, and Delete Time Segments. So on this menu that pops up, you'll see a number of criteria that you need to input. The time threshold is the minimum period of time with no triggers that will prompt EEGLAB to delete a data segment. Imagine you have a study where people see a prime and a target and then respond. You want to ensure that the time threshold is longer than the interstimulus interval between the prime and the target and the response period. On top of this, you need to make sure it's longer than the intertrial interval, so the point between the participant responding and the next trial beginning. For the present dataset, I know that our interstimulus interval, response time and intertrial interval are shorter than 1,500 milliseconds, so I'll set this as the time threshold. Buffer before and buffer after basically lets you dictate how much time you want EEGLAB to leave around triggers when deleting segments of data. Because we usually want a baseline period before our trigger, we might want to set this to about 500 milliseconds. That means that when EEGLAB spots a trigger, it will go back 500 milliseconds before it and only delete up to that point. With my behavioural response as the final trigger in the trial, it doesn't really matter so much what time I set my buffer to, but if my target, for example, was the final trigger, then I would want to leave sufficient time so that I don't cut into the period of interest, so perhaps 1,500 milliseconds. Decide your after buffer period based on how long you want your epoch data segments to be, if that's the case. The event code exceptions you should only use if you've got triggers that you don't want EEGLAB to consider when it's looking for these periods of time without a trigger. So if for whatever reason I have a trigger 33 in my dataset and I'm not actually interested in that, it's just a break trigger or something, then I'll want to pop that into the box and make sure that it's set to ignore these exceptions. And that means if it finds a 33, it won't count it as a trigger and it will continue to delete through that segment of data. You then want to ensure that display EEG and ignore boundary events are ticked. The ignore boundary events box just means that if you have a break in your EEG data, you might have paused the recording for some reason, it's not going to count that as a meaningful trigger. So then you want to press run, and you can now see the data that will be deleted highlighted in red. Have a scroll through this using the left and right arrow buttons just to make sure that you're not deleting anything that you actually would much rather prefer to keep, and you don't need to adjust any of the buffer periods or time intervals. If it's okay, press OK. If it's not okay, press cancel and go back and change the input criteria. You might now want to inspect your data. I suggest this because there might be 1 or 2 crazy events that fall when the triggers do that you also want to remove. Remember that when you do this, you're removing these trials from your dataset permanently, so you really don't want to delete too many. You may also want to look for any blinks that have been cut in half by the data rejection process and remove these. To reject a period of data, click and drag, and to deselect the data, click on the highlighted section. This click to deselect function can be quite annoying because if you want to delete a continuous stretch of data, you'll want to join the chunks of highlighted segments up, and unless you do this carefully, it's very easy to deselect the previous chunk. To scroll, press the left and right arrows. And finally, at the same time as rejecting bad stretches of data, you can also use this step as an opportunity to identify any bad electrodes. It's important to do this for two purposes. One, so that they can be excluded from the ICA decomposition, and two, for subsequent interpolation, which is a process that I explain in a later video. Here I can see that T8 isn't a particularly good electrode, so I want to make a mental note to exclude this when I run the ICA in the next video. Once you've done all this, press reject and save the dataset as whatever you want it to be saved as. For me, if you're following the tutorial step by step, you'll save the dataset as P1 pre-proc1. I use this label to keep track of which stages of the pre-processing pipeline the dataset has undergone. It's important at this stage to save the dataset because this is the dataset we're going to call when we run ICA.